here to fire the boilers of textile mills.
The textile industry had found a way to allow the new steam engines to power their machines. With the canal able to provide coal and raw materials, massive weaving mills sprang up.
This one is at a museum, the Queen Street Mill. There's only one boiler working now, and that gets through 10 tonnes of this a month. But when both boilers were going at full steam, the boilerman down here got through 6 tonnes of coal a day, 6 days a week. Steam power had finally arrived in the textile industry. And this is what the boilers are generating steam for. It's a tandem because there are 2 cylinders, one in front of the other, like a bike. Compound because the steam is used more than once. Condensing because downstairs is James Watt's separate condenser, creating a partial vacuum in this, the big cylinder. Steam engine. All right, Owen. It develops 500 horsepower and it drives this 4-metre diameter flywheel. And I can feel the air off that.
This engine, powered by coal, transported on the canal, was built by Roberts of Nelson in 1894 and drives the looms of this Lancashire cotton mill.
Mesmerising, isn't it? That's the crosshead. Connecting rod to the crank there, which is turning the wheel. All that power. Then you look down here, and these are going the wrong way. What's that all about? Well, what's happening with it going against the piston movement is that he's controlling the inlet valves and the exhaust valves. So it's got to work against the piston because you've got to put the steam in behind it. Hang on a minute. Right. OK. So that's coming backwards and lifting. Every time it lifts, that's an injection of steam behind the piston one way and the other side the other. OK. So what's happening down there? Well, you've got to get rid of this steam as well. So these are the exhaust valves. Ah, but they look like they're both going the same way. And you think, oh, that's not right. But they're set at 180 degrees. So when one's open, the other one's closed. So the rod can just work together. Good, isn't it? And this is my favourite bit. Dancing metal. It's like little punches, isn't it? She's even got a name. And I think it's a measure of the respect that the Victorians had for these masterpieces of engineering. She was originally called Prudence, after the wife of the engineer, but was renamed after the 1918 armistice. Of course, the other side of the wheel wasn't quite so measured and tranquil. Because this is what it's driving. 300 power looms. You can get an idea of how loud it is, but you can't feel the concrete floor vibrating. These are much more advanced than the pedal looms, weaving at 180 picks per minute, as opposed to 120 for the pedal loom. Now, everything is powered by steam. All the weaver has to do is change the weft in the shuttle and maintain the loom. So Loom!
The power loom was invented in 1786 by a rector, Dr. Edmund Cartwright. It wasn't just a case of connecting a steam engine to a pedal loom. Weaving 50% faster required a loom with greater tolerance. Mill owners loved it, especially the cotton barons of Lancashire.